Thanks, Leanne. And with that, we'll open up time for the panel discussion. So it's open for questions.
Dr. Ranveer Chandra, I want to go back to my previous question, mass versus volume. Mass versus the common measurement, and it has a limitation because we need to manage water on volume basis. So if you monitor on mass basis, is there any possibility of including bulk density measurements of the same site by the same technique so the data can be converted to volume basis?
No, that's a good question. Actually, I got it wrong. It was volumetric moisture, not mass. So I think, so that's what we do right now. Although it is volumetric. The challenge, so I want to bring in the caveat that it is the first research that showed that you can measure that with Wi-Fi. The thing is, we still need a tag in the ground to measure that. So that's why I think in the future, what we want to get to is don't put anything in the soil. Just bring your phone close to the soil, and using the reflected measurements, you can say something. So we are still farther away from it. Right now, you need a tag inside soil. This goes above the ground, and using that, you can measure it. I'll send you that paper. Would love your thoughts on it. It's still, I think it shows that Wi-Fi has that property. Someone would have to take it to the next level to really commoditize sensing, right? If you're talking of a future where anyone can just bring their phone close to soil and get measurements, we are still some time away from it.
Ethan?
All right. Well, this is a question for the physiologists. I'm wondering what specific technologies or breeding objectives are there out there specifically focused on water-limited yield potential? Are there traits that are really promising in the way that you highlighted, Don, some really exciting targets for looking at total yield potential? What about specifically water-limited yield potential? And Sue mentioned the silicon drought resilience, but I wasn't quite sure about the mechanisms there. I know there are other things thinking about VPD and stomatal conductance, and what's kind of the next frontier of that?
I can try to give you a partial answer. And so many of the targets for engineering photosynthesis bring along with them increases in water use efficiency. And so whether it's this photorespiratory bypass that I talked about, any increase in energy light use efficiency within the canopy, all other things being equal, there will be less water use. Having said that, everything isn't equal, because when you engineer more efficient photosynthesis, you grow a bigger canopy, and so you have more evaporative demand. And so you can have at the same time plants that are more water use efficient but use more water on a land area basis. And so that's a partial answer.
I could just take the silicon question. So there's a variety of mechanisms that are thought to be important in silicon improving resistance to drought. One is simply quite a structural mechanism. It strengthens plant roots, and they can improve penetration into dry soil. We've just done, we're in the process of doing an assessment of all the published literature on the mechanisms highlighted in studies on silicon and drought. And the biggest effect, I'm just looking at curiously, my student just literally sent me the results this afternoon, so I can look at them on screen. So one of the mechanisms that's reported is an improvement in stomatal conductance and in water use efficiency, a reduction in oxidative damage, an increase in chlorophyll content, and a big change in antioxidative enzyme activity. So I guess that doesn't help in some ways, in that that's just a range of physiological mechanisms that silica impacts on. It's not the most useful answer to your question, but there is at least across the literature sort of fairly consistent responses in plants.
I want to add one more. An example from rice. It's not my work, but it's a work showing that the gravitational pull on the root systems to make roots grow down rather than out has an impact on the way that plants respond to, if there is water in the deep soil horizons, they can get to it. So deep rooting, and mechanistically, there are genes cloned that they know. And I think maybe, Giles, we should ask you, because I think some of the work that you reported also had to do with water use efficiency. You said that the mycorrhizae also increase the ability to...
Yes, you're right, sorry. No, there's some evidence that mycorrhizae can enhance water uptake, improve efficiency.
Yeah, I mean, I think these are all incremental in some ways, or additive. You know, nothing that anyone has suggested would cancel out the other. So collectively, I think drought is not one thing, it's many things, and it depends time and duration. I mean, you know all that, but I wanted to bring all the mechanisms that are known. David, did you have something to add? Anyone have something to add? Anything to add to that? Okay, on to the next. Yes?
So, Steve
I don't know your name.
Steve McGrath from Rothamsted Research. Coming back to sensors, I wanted to ask about the sensors you mentioned. They were for temperature, moisture, and conductivity. They're kind of the easy things, right? What we would really like is sensors for nutrients. And is there any progress on that?
Yeah, so this is where we are partnering with other universities, and most of the activity here is happening in the universities and some startups on new ways to sense nutrients. There's this company called Teralytic, which is doing something there. Iowa State's come up with something. At Cornell, there is this in-plant sensors that's been developed. And we are monitoring everything in that space. I think you're right that we need to get to the place where we can measure everything. And we are still in the early stages. Yeah, you can so there are different ways of sensing, right? It could be like even imaging is a way of sensing, and using images, what all can you infer from different bands? I think that's an open question as well. And there's some progress, but I think we still have a long way to go. Like someone in the break was asking me about carbon sensors. Well, that's again, we need that.
I'm going to add one thing. I can't remember if I talked to someone here or the day before I came here. I must be quite confused, but if anyone told me this, you'll have to step in. It's about ionomics and measuring micronutrients. Wasn't here. Okay. So we usually use a mass spec to measure ionomic profiles or the micronutrient concentrations in leaves or roots or shoots or green. And I learned just it was the day before, at Cornell, that there is a new technology that you can use that is very effective to get these ion concentrations. And I can't remember if it was like an X-ray based thing. It takes 30 seconds, it's cheap, you walk out there and you get it. So there's an opportunity. Maybe you know more than I do.
Yeah, we've been working for a few years now with Gates funding. So we were leading, for example, there's a program called AFSIS. So we were doing what I call dry spectral analyses in Africa, where you can't run an ICP-MS, right? You just cannot. So basically what we're using is portable XRF, which gets you a lot of nutrients and some of the micronutrients, but there are limitations. The signal from some of the ultra trace elements is too small. So there are limitations. And with mid-infrared, basically we're looking at a very wide spectrum and being able to calibrate that against the wet chemistry, so your ICP-MS, right? And those sort of things are now becoming available. You can use them in labs which are quite remote, not completely remote. And I think they have a lot of promise for bringing down the cost of analysis and making it more available, particularly in remote locations. And so if you can do that, you can do more monitoring. It's not online like you were talking about in sensors, but it's a quick way of doing things, which is rather inexpensive.
Yeah, and I talked to one of your colleagues, I think in Holland, at the AFSIS, who was working in AFSIS as well. Through the Gates Foundation, we got introduced to them. We are monitoring the work you're doing there. We'd love to see especially these low-cost hyperspectral cameras, which can then start doing this analysis. I think that is very promising.
Can I just add that a portable XRF is the method of choice for rapid silicon assessment as well, and phosphorus. Very handy technique.
Alison?
This one's a bit out there, but it's for Ranveer. So I'm listening to producers, and there was recently an issue with a company that was partnering with Climate that was sending out lease offers to different landowners in the absence sometimes of the leasees knowing that that was going to happen. And amongst the kind of the clientele that I've been working with in Extension, I hear this incredible distrust of big data, and that Silicon Valley just wants to get their hands on my data so they can monetize me. And I just wonder how much that kind of narrative is potentially going to get in the way of actually utilizing big data in agriculture for the types of applications we're discussing here.
Right. No, that's a very good point. And I get asked about data everywhere I go, and it's an important question. The thing is, so on the one hand, we need to be careful about how this data is handled. That is, especially because it's not just data, but what insights you can derive on top of this data. Like with artificial intelligence, I showed you some of the things today, and this is still early there are many more things that you can do, things that you never knew you could do. And it's the same thing with, for example, facial recognition. You can use facial recognition to unlock your phone. You can use it to track people where they don't want to be tracked. And so with data, I think we need to be careful about how that data is used, and it's good that everyone's talking, and this is a problem that everyone's getting more and more aware of. At Microsoft, what we are doing is we are not in the process of owning the data. Like the FarmBeats I talked about, the system is deployed in the customer subscription. So for example, if there's another company that's using FarmBeats, it would be running in their subscription. So Microsoft doesn't even see the data. What we are providing is we are providing hooks. Like, for example, I showed you that PC, which is the edge device, which sits in the farmer's house. We are providing the mechanisms where you can select and say, this data goes here, this data doesn't. So we provide that infrastructure. The other thing we are also providing is in the cloud, say, suppose there's an agricultural company that has the data, they can securely share the data with someone else. You can then see who accessed the data, where the data was leaked. So we are providing all those provisions. But exactly who owns the data is something that we are not a part of, but I think the community as such should be careful in how this data is handled. And there are various ways in which you could do this, right? On the one hand, farmers would benefit from getting this data in the right hands. If you could get the AI on top of this, you could provide insights which the farmer could benefit from. And right now, this data is also siloed. For example, a tractor company has some of the data, the seed company has some of the data, some of the other data the farmer never reveals to anyone because it just sits with them. And if you could combine all of these is when you could generate the most insights. On the one hand, you can say, well, you need policy, you need regulations, you need something around this so that the data is not misused. I think this is also a research problem. In computer science, there's a lot of research going on can you do machine learning on encrypted data? That is, even though the farmer doesn't share the raw data, even if they share the encrypted data, can you still do some AI on top of it? Or there's another work recently which was talking about, this is a professor at UC Berkeley, she's doing this work on coming up with the value of data. That is, can you pay the farmer back based on the data, the value of the data that they shared? How much did your model improve, and can you pay them back? So to summarize, well, it's an important problem. At Microsoft, we want to provide all the mechanisms. We don't know what the right answer is. That is, who should own the data. And the third is, I think there is this research problem that needs to be solved, which would involve people in sociology, in policy, in computer science, on can you do machine learning on encrypted data? I don't know if I answered your question. I know I didn't give you an answer on who should own the data. I think I think you should share the data because there's value coming out of it. On the other hand, who should own it is something which would depend on what value comes out of it. Who's making it? And yeah, it's still an open question. What happened there with the particular problem you talked about, that was wrong.
Following on from Alison's question, and we're having the same problem in the UK, but because of legislation, we're actually having to come up with frameworks to try and overcome this. Not that it's Alison's example. We have similar horror stories in the UK that we're trying, which puts us back months and months of discussion. So it's really, really important. I'm going to come at it from the science perspective, particularly for data science, and I'm a data junkie, so please don't take this as any sort of criticism, but validating when you've got, and if we go re-row or garbage in, garbage out, if I'm giving them in the States, how do we, so it's something as complex and integrated that you're trying to model with machine learning, with algorithms that are just, no way you can understand their mechanisms. How do you validate this experimentally, particularly when some of the technologies are so new that you're integrating?
Yeah, no, and that's a hard problem coming in from a computer scientist where we are used to running these experiments to validate the results. It's really hard. That's why if you saw in my results, there were no results on how much yield did we improve, what was the impact on pests. These are things that people in the room know how to run these detailed scientific experiments. And we don't have an answer to that yet. We are running one controlled experiment, but that's not something which is representative. And the other problem, the reason it's hard is because it's in agriculture. That is, AI, as you know, because you're a data junkie, the how good your model is depends on how good your data is.
Yeah.
That's if your data has a bias, your AI models will have a bias.
Yeah.
So that's a fundamental problem. And the biggest problem there with agriculture is that a lot of data just doesn't get to the cloud. You're getting such sparse data from the middle of the field. That limits the kind of models that you could build. That limits the kind of verification that you could do. So we are limited in the kind of things that we can infer right now. Like, for example, I talked about the heat maps. We only did it for 3 different 5-acre plots in 3 different spots. Well, that's some amount of validation. That's not, and we did do a few more with some academics, but it's not representative saying it would work everywhere in the world. So we put that caveat. We're like, well, it works we know why it works, but beyond that, the actual validation would have to be done. But some of the other things like the microclimate prediction I talked about, that's much more detailed. We have weather station data, a lot of weather station data, and we can use that to do the validation. So that's where I think this is one of those interdisciplinary efforts where computer scientists need to work with agriculture scientists who understand the space really well to actually formulate the experiments. And that's the thing that is missing right now. If you saw in the presentation, we didn't go answer that question, okay, how much yield does it improve? How much water consumption does it reduce? Well, we don't know. We build the maps. Beyond that, we have no idea. That's why we need the people who are agricultural scientists to build things on top. Right now, that's why we are working with academia, with Cornell, with Purdue, with UIUC, the agriculture schools, to try to understand that, to try to answer that problem.
Can I just come back and because obviously we have got empirical scientists in the room and we also have funders in the room. This space is something that can sit uncomfortably as people try to innovate in this space, so it's really important.
So one way to frame a question around a fundable research question that I think is important here is that if we look at the medical models where they share highly personal data, they strip identifiers and they can anonymize the data. So we've been looking at ways to do that. Of course, the problem with farmer data is it's all GPS coordinate. And that GPS is incredibly important in order to make all the weather and other data fit it.
Yeah.
So the researchable question is, how do you anonymize data, maintaining relationships among data, but stripping the GPS and other things from it? And I think it's not a solved problem.
Yeah.
But the way the medical people went about it at the beginning was not a solved problem, and it was maybe even more. I just think people have been overwhelmingly very concerned about that from day one in the medical arena as well. So there's somebody in the back. Yes. Yeah.
I have another question, which you've alluded to. But farmers, as we've seen, are sort of on the very low end of the value that they get out of their crop compared to the rest of the food system. And it feels to me like this could be another way. I mean, I understand the software companies come in, find out how they can improve farmers' yield, and they get all the profit from the increased yield because they sell the software year by year to the farmers. And so I think farmers might very well be leery of providing you their data because you're going to make money off of them by doing it.
I don't think they should be providing us the data. We, by ourselves, won't be able to do much with the data. The software companies, I know there are some other software companies that might say it's different. I think it's the problem of the agriculture companies who they deal with, who will do more with the data. And that said, I think if the farmers see the value of sharing the data is what would incentivize them to share. And that's a question for researchers as well. How do you create the value on top of that data? So that's one part. And the other part, I guess, what Susan McCouch was referring to was, can you even create this shareable data set that is independent? That is, if you can create a representative data set, and this answers your question as well, that could be one way to help scientists in the space build more models. And that has to be a representative data set for different crops, for different soil types. And if someone can create that, I think that could help a lot of research in the space. And it could be coming from land-grant universities here or similar universities in the UK, where you're trusted, you're researchers, you might have your own research farms spread out, and you could be the ones who are hosting this data set. Some of this could even be research farm data, which I think could be valuable as well.
We're just about
one other point. Sorry, could I just make one point? One way to increase value and uptake and engagement that we haven't talked about much yet, and maybe it's just a kind of subtext and it's all going on and we just haven't mentioned it, but that's the concept of co-design with farmers. We've done quite a lot of research on this at York and at Sheffield. If farmers feel engaged right from the start in the process of designing the data collection and having some say into what's going to become of that data, that sort of engagement can be very powerful in designing a system that's going to be trusted and taken up. So just a plug for co-design.
Yeah, just my question is, I think it's for yourself. Yeah, I think it's a very good thing that Microsoft is developing this, but where are your experimental sites? Are they only for US and UK, or are you really catering for the global farmers?
Yeah, we are working with partners in different parts of the world, and most of our partners right now are here and in UK. I was in Australia 2 weeks back. We are working with Cyro in Australia. So we are working with people who understand agriculture in different parts of the world to get them. Essentially, if you see what FarmBeats is, it's a way to make agricultural scientists and companies more productive. And we are working, right now, we don't have many partners in Africa. We just started something in India, so. Yeah.
I think it will be just good for Microsoft to really look at the developing countries, because that's where the challenge is. I think developed countries have already a mechanism to sort out their problems. So if Microsoft is willing to do that.
That's a good question, because today someone asked me, I didn't know, why is Microsoft here in this agricultural conference? People didn't know that we do this. So to some extent, you should realize that Microsoft's mission is to empower every person and organization in the world to achieve more. And if you think of that, food is just fundamental part of it. So Microsoft is investing in this. We are investing heavily in India and Africa. In Africa, we opened a huge data center. We have an engineering group there. I have a team in Kenya. So that's, of course, very important for us. The thing is, it's just harder to use the technologies that I talked about for smallholder farms. Of course, if you can get this Wi-Fi sensing thing to work, that would be a big breakthrough. If you use satellite data, if each pixel corresponds to some part of an acre, and you could have multiple crops in it. So satellite data by itself might not be as useful in some of these scenarios. So there are some interesting problems. A lot of them are research problems that would have to be solved to use these technologies that I talked about for really small farms. But that's an important problem. Completely agree. We all need to work towards that.
A question for Tom. Tom, you described a number of multidimensional axes that are necessary to address and deploy sustainable systems. Simultaneously, you inferred. And I'm wondering if you've thought about the institutions that are ready and able, perhaps, to coordinate that sort of activity, or whether you think it's even necessary.
Yeah, that's a good question. I don't. What those institutions would look like is a challenging question. I definitely don't think we've got that level of coordination at the moment, and I think that there's a lot of siloed aspects to not just the policy systems that need to deal with this problem across departments and also across international governments not necessarily coordinating sufficiently, but even in research silos as well. Just listening to conversations here, it's fascinating, this science. It's almost wizardry what you can do in terms of changing the forms of crops so that they can change their growth forms and yield more and grow them vertically. But there is a real challenge. I think I wrote down we need to increase food demand will go up 30% by 2030 in 10 years from now. So can all these technologies deliver that yield increase within 10 years? And if not, we're going to have hunger. And when that happens, there'll be a huge incentive to just extend food production as much as we can at the expense of biodiversity and water quality and air quality. So, these are all part of the solution, but I think we do need to be more holistic. I guess coming to your question more directly, it's a challenging one. I'm working in this systems research program that Ian Boyd set up, which is trying to coordinate across policy teams within UK's in DEFRA, Department for Environment, Food, Rural Affairs. But even we were just talking at lunch, there's real issues that's just within DEFRA, but also you could do everything. You could make a lot of progress within DEFRA, but then if you're not talking to the people who are working on international trade policy, you've kind of lost the game already. So there is a need to kind of build these links in a much more holistic way. And sometimes I think we work on this kind of incremental paradigm, and actually we'd be better almost redesigning the system and thinking, what are the kind of major step changes that we need? I'm not sure is the true answer. Good question.
Could I just make one quick comment on that? I think Tom made a very, very good point there about just even our political and governmental institutions are not kitted out for this. We did a kind of systems mapping of the policies that DEFRA want to implement and want to evaluate, and a large proportion of the policies they wanted to run were not under their control. They were controlled by effectively other departments within government. So working out a way for us all to be more joined up is a high priority, although very challenging.
There are a lot of actors in this game, and some are, most we would hope are good actors. Some are bad actors, and probably the majority are, perhaps not the majority, but a number are indifferent, and allowing the natural state of affairs to go its course. We're likely to be where we are now, 20 years from now.
Yep.
I think I'm taking over now.
We'll close the panel. Thank you to all the panelists, both on-site and off-site. We're going to hear a few words of wisdom from David Tillman now. Thanks.
I want to give a hand to the panelists.